Welcome to another informative series brought to you by Autruo. In this series, we will be looking at torques. The application of torque in a factory settings will be discussed in detail. And in the same vein, we will also be looking at the equipment that the torque generating devices are usually attached with. Stay tuned.
So Alex, what is going to be the total torque that will be required for that project? Because I intend to use the data during gearbox selection. You know the torque ratings of the device that will be driving the gearbox will also be very important during gearbox selection.
Well, it depends on your application. Is your project going to revolve around speed or high moving force, which can also be known as power? This will influence the ratings of the electric motor that will be needed for the project.
Okay. I know that you are a motor specialist. I won't mind if we look at electric motors in detail.
Okay, perfect. An electric motor, as we all know, is an electromechanical device that converts electrical energy into mechanical energy. That is when the coil is energized. Mechanical torque will be generated, which will cause the torque of the motor to spin around its axis. However, before we dive in, let's look at how electric motor came to be. In 600 BC, a Greek man named Thales discovered that amber, when rubbed with silk, the amber will attract feathers and other light objects. The force attracting the feather and other light objects is what is known as static electricity today. Also, the Greek word for amber is electron, which is where words such as electricity and electron come from. Later in 1600, William Gilbert, who was a scientist and physician to Queen Elizabeth I, he invented the term electricity. He was the first person to recognize that there was a connection between magnetism and electricity. And also, he was the first to describe the Earth's magnetic field. In 1700, machines to produce static electricity were first introduced. At first, they were used just for fun and nicknamed parlor trick machines. However, over the century, they developed and advanced. During this time, Francis Hawksby invented neon light. He created electrical effects by placing mercury into a glass globe, pumping out the air, and spinning it. When he did this in the dark and then rubbed it with his bare hand, it glowed. Little did he know that he had invented neon light, without even knowing it. Later in 1752, Benjamin Franklin, a famous U.S. politician, proved that lightning is a form of electricity by flying a kite with a metal tip into a thunderstorm. In June 1752, he is reputed to have attached a metal key to the bottom of a dampened kite string and flown the kite in a storm-threatened sky. A succession of sparks jumping from the key to the back of his hand showed that lightning was indeed electrical in nature. He also explained the apparently paradoxical behavior of the Leyden jar as a device for storing large amounts of electrical charge in terms of electricity consisting of both positive and negative charges.
Perfect. These guys really did a lot of research work. The Leyden jar experiment can also be related to the capacitors that we use today, while the former, which is the research work of William Gilbert, can also be attributed to the creation of the science of magnetism.
In 1800, Pyle Volta created the very first simple battery using pure silver and zinc discs, which are placed between muslin which was dampened with a salt solution. This was developed from Galvani's experiment with the frog's legs. Later that same year, Sir Humphry Davy discovered electrolysis. When he passed an electrical current through some substances, they'd begin to decompose. This became known as electrolysis. Davy's experiments later led to the discovery of a range of elements, including calcium, magnesium, strontium, and barium.
For me, I can say that this era was when chemicals were used to produce electricity. However, the reason why chemicals have not been widely adopted these days is because the current produces less and the current carrying capacities are also limited. And finally, the running cost is something else. I believe there should be a lot of research work in these areas, because our environment has been greatly affected by carbon emissions. Hence the need for a more cleaner electricity generation which does not require the need for a relative movement between a magnetic field and a winding.
In 1820, Hans Christian Oersted, who was a native of Denmark, he found that when electricity flows through a wire, it generates a magnetic field that affects the needle of a nearby compass. The following year, Michael Faraday discovered that when a magnet is moved inside the coil of a copper wire, a tiny electric current flows through the wire. This discovery led to the invention of electric motors and generators.
I remember my college days. Most especially Faraday's law of induction, which predict how a magnetic field will interact with an electric field. And Faraday law is related to chemicals. That is, chemical change is proportional to the quantity of electricity used.
Faraday was an excellent experimentalist who conveyed his ideas in clear and simple language using his mathematical abilities. However, these did not extend as far as trigonometry, and were limited to the simplest algebra. James Clerk Maxwell took the work of Faraday and others and summarized it in a set of equations that is accepted as the basis of all modern theories of electromagnetic phenomena. On Faraday's uses of lines of force, Maxwell wrote that they show Faraday to have been in reality a mathematician of a very high order, one from whom the mathematicians of the future may derive valuable and fertile methods. The SI unit of capacitance is named in his honor, the farad. So basically, just like Andrea said earlier, magnetism is widely used these days. That is for power generation as in generators, or for torque generation as in electric motors. Electromagnetism has formed the basis of everything these days. In the coming series, we will be looking at how electric motor works, and the various motor starting method will also be discussed in detail. Hope you have learned something new today. See you in the next one.